Welcome to Aeronet's visual simulation training program for the Airbus A320. The air conditioning system supplies the aircraft cabin with a continuous temperature-controlled supply of fresh air. The air-conditioned supply of air is distributed into 3 independent automatically controlled zones: the cockpit, forward cabin, and aft cabin. The air conditioning system is supplied with hot air from the pneumatic system, which is cooled by 2 independent air conditioning packs. The hot pneumatic air first passes through the pack flow control valves, then through the air conditioning packs. The fresh air from the packs is mixed in the mixer unit with recirculated cabin air. The conditioned air from the mixer unit is temperature regulated by the hot air regulating valve and trim air valves, which use hot pneumatic air tapped upstream of the packs. The air conditioning system is controlled automatically by 2 pack controllers, 1 for each pack, and a zone controller. The air conditioning system is controlled by switches located on the overhead air conditioning and ventilation panels. The air conditioning system's operation is displayed on 4 Ecam pages: the conditioning page, the bleed page, the cabin pressurization page, and the cruise page. The main components of the air conditioning system are the 2 independent automatically controlled packs. The packs are located in the unpressurized belly area just forward of the main landing gear. Each pack is comprised of an air cycle machine, a primary heat exchanger, a main heat exchanger, and components for water removal. The heat exchangers use external ram air to cool the hot pneumatic air. Then the ram air is exhausted overboard. A ram air inlet flap is located just forward of each pack, and a ram air outlet flap is located just aft of each pack. The packs are supplied with regulated hot pneumatic air by the respective pack flow control valve. The regulated air from the pack flow control valve enters the pack's primary heat exchanger, where it is cooled by external air from the ram air inlet. The cooled air from the primary heat exchanger enters the compressor section of the air cycle machine, where it is compressed to a higher pressure and temperature. From the compressor, the hot air is cooled again by the main heat exchanger using external ram air. After the air leaves the main heat exchanger and before it enters the turbine, it passes through a reheater and condenser, which converts any moisture in the air into water droplets. The water droplets are collected by the water extractor and then sprayed into the ram air inlet to increase the cooling efficiency of the main and primary heat exchangers. After water removal, the air passes through the turbine section of the air cycle machine, where it expands, powering the compressor and cooling fan. The removal of energy during expansion cools the air further, and it is then ducted to the mixer unit for distribution to the cabin. A review of the airflow through the air conditioning pack has the hot pneumatic air entering the pack through the flow control valve and being cooled by the primary heat exchanger with ram air. The partially cooled air is then compressed by the compressor and cooled again by the main heat exchanger. Leaving the main heat exchanger, the air passes through a reheater and condenser, where any water is condensed and then removed by the water extractor. After water extraction, the air enters the turbine where it expands, driving the compressor and cooling fan. After the expansion in the turbine, which causes the air to cool further, it is ducted to the mixer unit. The bypass valve modulates the pack outlet temperature by removing air before it enters the compressor and adding it downstream of the turbine. When ice is detected on the condenser, the anti-ice valve will open, adding hot pneumatic air downstream of the turbine, thus preventing ice buildup across the condenser. The anti-ice valve will also maintain the pack at a fixed temperature in the event the pack controller is unable to control the bypass valve. The pack flow control valve is pneumatically operated and electrically controlled by the pack controller from the air conditioning panel. The pack flow control valve regulates airflow to the pack according to signals received from the pack controller. The pack flow control valve will close automatically if pneumatic pressure is low, the pack overheats, or during the engine start sequence. The valve will also close if the engine fire or ditching push buttons are operated. The mixer unit mixes temperature-regulated air from the packs with recirculated cabin air from the cabin fans, which are controlled from the overhead ventilation panel. The mixer unit can also receive conditioned air from an external air conditioning unit or ram air from the emergency ram air inlet. The emergency ram air inlet is used during emergencies to supply the cabin with external air for cabin smoke removal or when both packs fail. The ram air push-button switch on the air conditioning panel controls the ram air inlet valve. The hot air pressure regulating valve is pneumatically operated and electrically controlled by the hot air push-button switch on the air conditioning panel. The valve supplies the trim air valves with hot pneumatic air which is tapped upstream of the packs. The valve will close automatically if the duct overheats or in the absence of pneumatic pressure. The electrically controlled trim air valves add hot pneumatic air to the conditioned air of the mixer unit, satisfying the demand for individual zone heating. One zone controller and two pack controllers automatically control the temperature and airflow of the air conditioning system. The zone and pack controllers are dual primary and secondary channel controllers. The secondary channels act as a backup to the primary channel, controlling at a reduced level if the primary channel fails. Each pack has an associated pack controller which will control airflow of the pack by modulating the pack flow control valve. The pack controller controls the temperature of the pack as demanded by the zone controller by modulating the position of the turbine bypass valve and the ram air inlet and outlet flaps. The pack controller also closes the ram air inlet flap during takeoff and landing to prevent foreign object ingestion by the packs. The zone controller regulates the temperature of the three zones by sending signals to the pack controller and trim air valves. The zone controller uses temperature selector position and cabin temperature information to regulate the pack output temperature and optimizes it with the trim air valves. If more heat is required in a zone, the trim air valve will open to add hot bleed air to the pack conditioned air. Touch the aft cabin zone temperature selector to increase the temperature in the aft cabin. The zone controller regulates the airflow in accordance with the position of the pack flow selector switch on the air conditioning panel. If the zone temperature cannot be satisfied, the zone controller can automatically increase airflow by increasing the speed of the APU or engine idle to increase bleed pressure. The pack push-button switch, located on the overhead air conditioning panel, is normally in the on lights out position. With a switch in the on position, the associated pack flow control valve will be automatically regulated towards the open position depending on required demand. In the on position, the pack flow control valve will automatically close if the pneumatic supply pressure is low, the pack overheats, or during the engine start sequence. The valve will also close if the associated engine fire push-button switch is pressed, the ditching push-button switch is selected on, or selecting the pack push-button switch to the off position. Touch the pack push-button switch to turn it off. The pack push-button switch amber fault light will illuminate, and the associated Ecam warning will be displayed for a disagreement of the pack flow control valve with its commanded position, a pack compressor outlet overheat, or a pack outlet overheat. The Ecam bleed page displays the pack flow control valve inline green when the valve is not closed and regulating air pressure. The valve is displayed crossline green when it is fully closed. The indications are displayed in amber when the valve disagrees with the commanded position. The hot air push-button switch located on the air conditioning panel is normally in the on lights out position. With the switch in the on position, the hot air pressure regulating valve opens and regulates hot air pressure to the trim air valves. With the hot air push-button switch selected off, the hot air pressure regulating valve and the trim air valves close. The hot air push-button switch fault light will illuminate if there is an overheat of a duct which supplies the individual zones. With a duct overheat, the hot air pressure regulating valve and trim air valves will automatically close. If the hot air push-button switch is selected off, the fault light will go out when the temperature drops below the set limit. The Ecam conditioning page displays the hot air pressure regulating valve inline green when it is not fully closed and regulating pneumatic air pressure. The valve is displayed crossline green when it is fully closed with the hot air push-button switch in the on position. With the hot air push-button switch selected off and the valve closed, the valve will appear crossline amber. The valve is also displayed in amber anytime the valve is in disagreement with the commanded position. The zone temperature selectors allow the temperature of each cabin zone, cockpit, forward, or aft, to be controlled individually. The 12 o'clock position is approximately 24 degrees Celsius, with the cold and hot positions being 18 and 30 degrees respectively. The Ecam conditioning page displays the temperature of the individual cabin zones in green. The duct air temperature entering each zone is displayed in green for normal conditions and in amber if the duct temperature exceeds 80 degrees Celsius. The pack flow selector allows control of the pack valve flow depending on the ambient conditions and the number of passengers. The low selection is 80% flow for light passenger loads. Normal is 100% flow, with high 120% for high demand conditions. When operating with only APU bleed supply or one pack operation, high is automatically selected irrelevant of the position of the pack flow selector. If operating in low and cooling demand cannot be satisfied, 100% will be automatically selected. The Ecam bleed page displays the pack flow with a green pointer on the top of the pack flow control valve indication. The pointer is displayed in amber if the valve is closed. The compressor outlet temperature is normally displayed in green and in amber if the outlet temperature is above 230 degrees Celsius. The top temperature indication is the pack outlet temperature, normally displayed in green, becoming amber if the outlet temperature is above 90 degrees Celsius. With the guarded ram air push-button switch in the off position, the emergency ram air inlet flap is closed. With the ram air push-button switch selected on, the emergency ram air inlet flap will open if the ditching push-button switch on the cabin pressurization panel is in the normal position and the cabin differential pressure is less than 1 psi. The pressurization outflow valve opens to 50% when not under manual control. Touch the ram air push-button switch to open the emergency ram air inlet. The Ecam bleed page displays the ram air inlet inline green when the emergency ram air inlet is fully open in flight. It is displayed cross-line green when the valve is fully closed. The indication is amber when the valve is fully open on the ground or when the valve is in transit. The pressurization system will pressurize the aircraft cabin to provide optimum passenger comfort by controlling the cabin rate of change in altitude. The pressurization system consists of 2 cabin pressure controllers, or CPCs, 1 outflow valve driven by 3 electric motors, an overhead pressurization control panel, and 2 safety valves to prevent overpressure. The pressurization system is controlled from the overhead cabin pressure control panel. The system is controlled in 3 modes: the normal automatic mode, the semi-automatic mode, or the manual mode. There is also a ditching push-button switch used in the event of a ditching to close the outflow valve and all other valves below the flotation line. The outflow valve is located on the right aft fuselage. The dual inward and outward opening flaps are linked by an actuator to 3 electrically driven motors, 2 being used for automatic modes and 1 used in manual mode. Outflow valve position information is displayed on the Ecam. Two independent pneumatically operated safety valves are located in the rear pressure bulkhead above the flotation line. The valves will operate automatically to prevent a cabin differential overpressure greater than 8.6 psi or a negative pressure greater than minus 0.25 psi. The cabin pressurization system is controlled automatically by 2 identical independent cabin pressure controllers, or CPCs. The controllers receive information from the flight management and guidance computers on the cruise flight level, the landing field elevation, and QNH. The air data and inertial reference system supplies static pressure and barometric correction information. The signal from the landing gear control interface unit is used to activate the flight ground mode, and the engine interface unit supplies thrust lever angle information to set the pre-pressurization mode. The 2 controllers communicate with each other through a cross-channel link. For operation in automatic or semi-automatic mode, one CPC is active with the other operating in standby. The change from one controller to the other is automatic after each landing or with a controller failure. When active, Controller 1 controls motor number 1. In the normal automatic mode, the crew only has to monitor the operation of the pressurization system as pressure in the cabin follows set external schedules. If data from the FMGC is not available, the system can be operated in the semi-automatic mode by manually setting the landing field elevation using the landing elevation selector. In the manual mode, the crew can control the cabin pressure by using the manual vertical speed control toggle switch on the cabin pressurization panel. In manual mode, the number 1 CPC has an independent backup section with its own electrical power supply and pressure sensor to supply information to the Ecam. The automatic pressurization mode is controlled by the active controller, its associated motor, and the outflow valve using data from the FMGC and ADERS or crew set landing data in semi-automatic mode. On the ground, the pressurization system operates in the ground mode, pre-pressurization mode, and the depressurization mode. The flight pressurization modes are climb, cruise, descent, and abort. On the ground, before takeoff, the ground mode commands the outflow valve to the full open position, preventing any differential pressure in the cabin, thus allowing the cabin doors to be opened. When the thrust levers are set for takeoff, the pre-pressurization mode pressurizes the aircraft cabin to a differential pressure of 0.1 psi, using a rate of change of 500 feet per minute. This pre-pressurization prevents a pressure surge at rotation. The climb mode is initiated at rotation, pressurizing the aircraft according to a fixed programmed schedule, depending on the aircraft's rate of climb and altitude. Reaching the cruise flight level, the cabin altitude is maintained to a maximum cabin differential pressure of 8.06 psi, or the landing field elevation, whichever is higher. When the aircraft is at its maximum altitude of 39,000 feet, the cabin will be maintained at approximately 8,000 feet. During descent, the cabin will be controlled at a rate of descent up to a maximum of 750 feet per minute to be at a cabin differential pressure of 0.1 psi just prior to landing. At touchdown, landing gear compression signals the depressurization mode to release the remaining 0.1 psi of pressure at a rate of 500 feet per minute. After the aircraft has been on the ground for 55 seconds, the outflow valve fully opens, reducing the cabin pressure to 0 psi, which allows the opening of the cabin doors. 3 minutes after touchdown, the cabin pressure controller transfers control to the other controller.
The abort mode is automatically activated and resets the cabin altitude to the departure airport elevation if the aircraft does not follow a normal en route climb after takeoff. This mode is activated if the aircraft is below 8,000 feet, or the aircraft has changed altitude less than 5,075 feet since takeoff, and the aircraft has a rate of descent greater than 200 feet per minute for 30 seconds.
When landing field elevation is not available from the FMGCs, the pressurization system can be operated in semi-automatic mode by selecting the landing elevation selector to the landing field elevation. Operation in semi-automatic mode uses the same schedules and CPC as in automatic mode. In the event of a failure of the automatic modes, the manual mode is used to control cabin pressure using the manual switches on the cabin pressurization control panel. Pressing the mode selector push-button switch to manual allows the use of the manual vertical speed control toggle switch up or down to control the outflow valve through the manual motor.
The ditching mode is used to prepare the aircraft for ditching. Pressing the guarded ditching push-button switch on the cabin pressurization control panel will close the outflow valve, the Avionics ventilation inlet, and the extract valves, the cargo isolation valves, the emergency ram air inlet, and the pack flow control valves. Note, with the ditching push-button switch on, the outflow valve will close only when the pressurization is in the automatic mode.
The landing elevation selector on the cabin pressurization panel is used to select the pressurization automatic mode or to select the landing elevation in semi-automatic mode. With the selector in the full counterclockwise auto position, data from the flight management and guidance computers is used to maintain an optimized cabin pressure schedule. If landing elevation and QNH data is not available from the FMGCs, the landing field elevation can be selected from a value of 2,000 feet below to 14,000 feet above sea level. The Mode Select push-button switch, in its normal lights out position, is in the automatic mode, using one of the two CPCs to control the outflow valve. Switching from one CPC to the other can be accomplished by selecting manual for at least 10 seconds, then reselecting the auto position. Selecting the Mode Select push-button switch to the manual position allows the crew to use the manual vertical speed control toggle switch to control the pressurization. The Mode Select push-button switch will indicate fault in amber with an Ecam warning if both automatic systems are faulty. The manual vertical speed control toggle switch, spring-loaded to the neutral position, controls the position of the outflow valve using the manual electric motor. With the Mode Select push-button switch in the manual position, moving the toggle switch to the up position will move the outflow valve towards the open position, causing the cabin altitude to climb. Moving the toggle switch to the down position moves the outflow valve towards the closed position, causing the cabin altitude to descend. Movement of the outflow valve is slow, so the manual vertical speed control toggle switch must be held in the desired position until the required vertical speed is reached.
The guarded ditching push-button switch in the normal lights out position will allow the pressurization system to operate normally. Selecting the ditching push-button switch to the on position will send a close signal to the outflow valve, the avionics ventilation inlet and extract valves, the cargo isolation valves, the emergency ram air inlet valve, and the pack flow control valves, which are all located below the flotation line. Note, with the ditching push-button switch on, the outflow valve will close only when the pressurization is in the automatic mode.
The Ecam cabin pressure and cruise pages display the landing elevation auto in green when the landing elevation selector is in the auto position. The elevation displayed is the landing elevation selected by the FMGC. When the landing elevation selector is not in the auto position, landing elevation manual and the selected elevation are displayed in green. When the manual select push-button switch is selected to the manual position, the mode and elevation are not displayed. The cabin differential pressure, or delta P, is displayed in green when in the normal range and changes to amber if the differential pressure is less than 0.4 psi or greater than 8.5 psi. The digital display will pulse if the differential pressure is greater than 1.5 psi below 800 feet during final approach. The Ecam cabin pressure and cruise pages display the cabin vertical speed in green for the normal operating range and amber if the vertical speed is greater than 2,000 feet per minute. The digital indication will pulse if the vertical speed is greater than 1,800 feet per minute. The cabin altitude is normally displayed in green and changes to red if the cabin altitude exceeds 9,550 feet. The digital indication will pulse if above 8,800 feet. The Ecam cabin pressure page displays the active cabin pressure controller system by green System 1 or System 2 label, which will turn amber if the system is faulty. With the Mode Select push-button switch in the manual position, the active System 1 or System 2 will be replaced by manual. The safety valves are normally displayed in the green closed position and in amber when either valve is open. The Ecam cabin pressure page displays the outflow valve position in green for the normal operating range, changing to amber if it is more than 95% open in flight. The aircraft has 3 separate ventilation systems: avionics ventilation, battery ventilation, lavatory and galley ventilation. The avionics ventilation system cools the electrical components of the avionics compartment and the instruments and circuit breakers of the flight deck. Cooling air is circulated by the blower and extract fans, which are automatically controlled by the Avionics Equipment Ventilation Computer, or AEVC. The blower and extract push-button switches located on the overhead ventilation panel control avionics ventilation. The Ecam cabin pressure page displays the indications of the ventilation system. The batteries are ventilated only when the aircraft is in flight by a Venturi effect, which draws the air from around the batteries overboard. The cabin lavatories and galleys are ventilated by an electric fan which draws cabin air from the lavatories and galleys and exhausts it overboard near the outflow valve. The fan runs continuously if electrical power is available. The cabin temperature sensors are located within the ducting which ventilates the lavatories and galleys. The cabin lavatories and galleys are ventilated by an electric fan which draws cabin air from the lavatories and galleys and exhausts it overboard near the outflow valve. The fan runs continuously if electrical power is available. The cabin temperature sensors are located within the ducting which ventilates the lavatories and galleys. The main components of the Avionics ventilation system are the Avionics Equipment Ventilation Computer, or AEVC, a skin air inlet valve, a skin air extract valve, 2 electric fans, the skin heat exchanger, which has an isolation valve, and skin exchanger outlet and inlet bypass valves. The Avionics Equipment Ventilation Computer, or AEVC, automatically controls and monitors the avionics ventilation system. The AEVC receives data from the landing gear position, the thrust lever position, and skin temperature and flow information, which it uses to control the fans and valves to maintain optimum avionics cooling. The AEVC supplies information to the Ecam and warning lights. The skin air inlet valve is located on the left side of the fuselage, just aft of the nose gear. The skin air extract valve is located on the right side of the fuselage, just aft of the nose gear. The extract valve has a small inner flap, which is used in some configurations. The 2 fans used to circulate air in the avionics ventilation system are the blower fan and extract fan, which run continuously when electric power is available. The blower fan blows filtered air to the avionics equipment, while the extract fan extracts hot air from the avionics equipment. The skin heat exchanger is used to cool the avionics ventilation air by skin contact. When the aircraft is in flight or with cool temperatures on the ground, air enters the skin heat exchanger through the skin heat exchanger isolation valve, which is controlled by the avionics equipment ventilation computer. The avionics equipment ventilation system operates automatically in 3 normal configurations: the open circuit configuration, the closed circuit configuration, and the intermediate configuration. The open circuit configuration operates on the ground when both blower and extract switches are in the normal auto lights out position and the skin temperature is above approximately 10 degrees Celsius. Outside air is drawn in by the blower fan through the skin air inlet valve, and the hot air is discharged overboard by the extract fan through the skin air extract valve. The closed circuit configuration operates on the ground when the skin temperature is below approximately 10 degrees Celsius, or when the thrust levers are set to takeoff power, or when the aircraft is in flight. In the closed circuit configuration, the extracted avionics air is cooled by the skin heat exchanger, then recirculated through the avionics ventilation system. In the closed circuit configuration, the skin air inlet and extract valves are in the closed position. If the AEVC detects airflow greater than required, part of the hot air is ducted below the floor of the forward cargo compartment through the skin exchanger inlet bypass valve. In flight, with a skin temperature above 35 degrees Celsius, the avionics ventilation system will operate in the intermediate configuration. The intermediate configuration is like the closed circuit configuration, except that due to the high skin temperature, some of the extracted air is discharged overboard through a small flap in the skin air extract valve. If blower airflow is low or high temperature is detected in the ventilation system, the blower fault light illuminates and the blower push-button switch must be selected to override. The blower fan stops and the Avionics ventilation system operates in the closed-circuit configuration. The extract fan continues to run. The air conditioning inlet valve opens to allow cool air from the air conditioning system to be mixed with the ventilation air. The skin exchanger isolation valve opens, and all other valves close. The Avionics equipment ventilation computer continues to control the ventilation system valves and extract fan. If extract airflow is low, the extract fault light illuminates, and the extract push-button switch must be selected to override. With the extract push-button switch selected to override, the extract fan continues to run, and as with a blower fault, the ventilation system operates in the closed-circuit configuration. The Avionics equipment ventilation computer has no control over the extract fan, but still controls the ventilation system valves and the blower fan. If the Avionics smoke detector detects smoke, both the blower and extract push-button switches indicate fault and are selected to override, putting the Avionics ventilation system into the smoke configuration. The blower fan stops while the extract fan continues to run. The air conditioning inlet valve opens, which allows air-conditioned air into the system, and all other valves close. A small flap in the skin air extract valve opens, allowing the contaminated air to be exhausted overboard. The Ecam cabin pressurization page displays the Avionics ventilation system indications. The label Vent is normally displayed in white and will change to amber for a blower or extract fan fault, valve position disagreement, or AEVC power supply failure. The Ecam cabin pressurization page displays the inlet valve in green when it is fully open or closed, changing to amber for valve disagreement or valve in transit. The label Inlet is normally displayed in white, changing to amber for a blower fan fault. The Ecam cabin pressurization page displays the extract valve in green when fully open, fully closed, or partially open. It is displayed in amber in case of valve disagreement. The label Extract is normally displayed in white, changing to amber for an extract fan fault. The aft cargo compartment is ventilated by an extraction fan which draws air from the cargo compartment and exhausts it overboard near the pressurization outflow valve. The cargo compartment air is replaced by cabin air, which can be heated by hot pneumatic bleed air. The cargo ventilation controller controls the operation of the inlet and outlet isolation valves and the extraction fan. Normally, on the ground and in flight, the isolation valves are open and the extraction fan runs continuously. The controller closes the isolation valves and stops the fan if the aft isol valve push-button switch is selected off, or if smoke is detected by the cargo compartment smoke detectors. The aft cargo compartment is heated with hot pneumatic bleed air, which is tapped upstream of the packs and mixed with cabin air before entering the cargo compartment. The hot pneumatic air is pressure regulated by the cargo pressure regulating valve, which is pneumatically operated and electrically controlled from the hot air push-button switch located on the overhead cargo heat panel. The cargo trim air valve regulates the amount of hot air mixed with the cabin air, thus maintaining the desired temperature as selected on the aft cargo temperature selector. The cargo heating controller electrically controls the cargo trim air valve and the cargo pressure regulating valve. The cargo heating controller will close the cargo trim air valve if a cargo isolation valve is closed, the cargo pressure regulating valve is closed, the extract fan has failed, the aft or bulk cargo door is not closed and locked, or the inlet temperature exceeds 70 degrees Celsius. If the inlet temperature exceeds 88 degrees Celsius, the cargo pressure regulating valve is also closed. With the aft isolation valve push-button switch in its normal auto lights-out position and no smoke detected in the cargo compartment, the inlet and outlet isolation valves will open and the extraction fan will run continuously on the ground and in flight. Selecting the aft isolation valve push-button switch to off will close the inlet and outlet isolation valves, close the trim air valve, and stop the extraction fan. With the hot air push-button switch in its normal lights-out position, the pressure regulating valve will move towards the open position regulating hot air pressure. Selecting the hot air push-button switch to off will close the pressure regulating valve and reset the fault circuit. The amber fault light illuminates and an Ecam warning is generated if the inlet duct temperature exceeds 88 degrees Celsius. Selecting the hot air push-button switch off when the duct temperature drops below 70 degrees will extinguish the fault light, at which time it can be selected back on to reset the system. The cargo heat temperature selector ranges from cold, which represents 5 degrees Celsius, to hot, which represents 26 degrees. The actual temperature in the cargo compartment may be 10 degrees lower than selected, as the temperature sensors are near the ceiling. The Ecam air conditioning page displays the aft cargo compartment temperature in green. The duct inlet temperature, normally displayed in green, changes to amber if the duct temperature rises above 80 degrees Celsius. The trim air valve position displayed in green indicates the range from cold, or valve closed, to hot, or valve open. It changes to amber if the valve fails. The Ecam air conditioning page displays the inlet and outlet isolation valves in green for the normal open position and in amber for the closed position. With the hot air push-button switch selected on, the Ecam air conditioning page displays the hot air pressure regulating valve inline green when the valve is open and crossline green when the valve is closed. The hot air pressure regulating valve is displayed inline amber if the valve has failed open and crossline amber if the hot air push button is selected off and the valve is closed. During the cockpit geographic check of the air conditioning panel, check that the pack flow selector is in the normal position if the number of passengers is 85 or more. Select Low for passenger loads of less than 85 and high for abnormally hot and humid conditions. With the APU supplying the air conditioning system, high is always selected by the pack controllers regardless of selector position. Check that the cabin zone temperature selectors are approximately in the 12 o'clock position or as required. The hot air push button switch should be in the on lights out position, and pack 1 and 2 push button switches should be in the on position, indicating fault if pneumatic pressure is not available. The ram air push button switch should be in the guarded lights out position. On the cabin pressurization panel, check that the manual vertical speed control toggle switch is in the neutral position with the Mode Select push button switch in the auto lights out position. Check that the landing elevation selector is in the full counterclockwise auto position and that the ditching push button switch is in the guarded lights out position. On the cargo heat panel, check that the hot air and aft isolation valve push button switches are in the auto lights out position. The cargo heat temperature selector is set as required for specific items in the cargo compartment. On the ventilation panel, check that the blower and extract push button switches are in the auto lights out position and the cabin fan's push button switch is in the on lights out position. From takeoff to landing, the operation of the pressurization system is fully automatic. The destination airport elevation is automatically set from the FMGC when the destination airport is entered. The normal crew requirement in flight is to check that the pressurization is operating normally during the cockpit check at 10,000 feet and every 10,000 feet during the climb.